Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 2nd, 2025, just yesterday. The big idea is a live, feedback-driven training framework that lets humans, or AI agents, intervene mid-run, which leads to steadier optimization, less sensitivity to brittle hyperparameter choices, and faster recovery when training goes sideways. The paper is titled Interactive Training Feedback-Driven Neural Network Optimization, and the implications for model training are quite significant. Beyond stability, the framework streams metrics in real time, supports on-the-fly data updates and checkpoint branching, and shows both human and agent control working in practice. Also, the author shared a GitHub repo. It packages the interactive training framework with a Hugging Face trainer wrapper, a FastAPI control server, and a React dashboard. You'll find install steps, a quick start, REST and WebSocket APIs, checkpoint and branching tools, plus runnable examples like GPT-2 on Wikitext, and an LLM-based tuner. So, Figure 1 contrasts static and interactive training with a kitchen analogy. Static training is like a closed oven, where you set a recipe once and wait, which risks wasted compute if the loss misbehaves. Interactive training is like a stove, where you watch signals and tweak knobs in real time, because hyperparameters can be adjusted mid-run. The takeaway is, control during training yields faster stabilization and fewer restarts. Alright, Figure 2 shows the front-end dashboard that turns passive monitoring into live control. The left pane exposes optimizer, model, checkpoint, and dataset tabs so a user can change the learning rate or clip thresholds on the fly. The right side streams metrics like loss and gradient norm, which is the size of parameter updates, and flags instability when it spikes. Because control and telemetry are fused, interventions happen in seconds and stabilize training. So, Figure 3 shows a closed-loop architecture, where the dashboard sends commands and the trainer streams metrics through a control server. It means interventions travel as RESTful requests and live WebSocket updates, so actions change the run within a step. The left block is the front-end dashboard, built with React and TypeScript, which issues learning rate or checkpoint updates. The middle block is the FastAPI control server that queues commands and returns metrics. The right block is the interactive trainer on Hugging Face Trainer, which applies callbacks after each gradient step, because synchronization keeps updates safe. Alright, Figure 6 shows that an AI agent adjusting the learning rate on the fly stabilizes training and lowers validation loss compared with a fixed, too large learning rate. The agent reads short log summaries and decides to halve, double, or keep the rate, which is a simple control policy that reacts to instability. The left plot reports validation loss dropping more steadily under agent control. The right plot shows sharp rate reductions early, followed by smaller tweaks as convergence improves. Together, these curves illustrate effective recovery from a bad starting schedule. Okay, two takeaways stand out. Real-time control over training makes runs steadier and less sensitive to brittle hyperparameters. And the same interface lets humans or agents fold in new data and checkpoints without restarts. The broader implication is training becomes a monitored, adaptive process that agents can increasingly automate. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.